Everybody, welcome to the OSS Summit. We're here for our PMM meetup. This is the first time we've done one of these live, so hopefully you can hear us and there aren't any issues. If there are, go ahead and just hit us up and chat. You know, um, we're trying something new today. So, um, thank you for joining us, though. I've got Michael here. Hi, Michael. How are you?
Hi, Matt. Glad to be here.
So you can see we're in the booth. We're here before anyone else is. It's 8 o'clock in the morning here in Seattle, and we've got our booth demo going. For the booth today, we've also got the controller where we are controlling all of the MySQL and Postgres workload that we're seeing behind us. And so what we wanted to do a little bit is just talk through this. So if you can give us a shout out in the chat, if you can hear us, we want to make sure that everything's working okay. Look at that. Wayne is here. Hey, Wayne. Glad to see you here. Like I said, this is going to be a little bit of a different show for us. Typically, I'm doing this from my office, so I'm going to go ahead and get that situated. Glad to have everybody here. And let's see what we got. Yep. All right. You guys can you hear us? Is that a hear you can hear us, or is that a no you can't hear us? That would be bad, right? A little bit louder would be nice, they said. So we can do that. We actually have the power with these microphones to increase the volume a little bit. It's on here. So let's go ahead and let's see about that. How's that? Is that better, everybody? All right, cool. So what we wanted to do here is we wanted to show you some of the things that we've done with PMM here at the show and show you how you could potentially do these yourself. So Michael has PMM up on his screen. So what I'm going to do is we're going to flip over to his screen, which is going to be mirroring what's up here because it's really hard to see what's behind us. But if you're not familiar with these meetups, basically these are designed to be shared. Share information, tell people how to work on certain things. We'd love to have people who are using PMM in the field, out there, come on the show and just share things. This isn't about anything that is scripted. It's all unscripted. It's just us talking and sharing and answering questions as we need to. So, Michael, let's go ahead and let's flip over to you so you can kind of show off some of the things you're doing. And so right now we're running Postgres workload, and it looks like we are just doing a little bit of Postgres workload, about 5,000 queries a second. So go ahead and take it away, Mike.
Sure. Thanks, Matt. So what we've got here is we've got a customized dashboard, which is part of PMM, which stands for Percona Monitoring and Management. And this tool is designed to give you a visualization approach to how your database is performing. Thanks to this beautiful box that we showed earlier, we're able to dynamically control the workload, and then we can reflect that workload through PMM. So what we're seeing at the top row here, we've got 3 different main characteristics of how you can look at your database. We're focused on how many users are connected. You see it in the top left screen here, DB cons. In the middle, you can see how many queries per second are running against your database. And on the far right side, you can see the response time. All of these factors are important because there are limited resources available to any given database. And what we can do, I'll be able to dynamically adjust the workload by turning some of these knobs here. And if you can see, it's probably a little bit faint on the back, but you can see that the screen's actually being modified just a little bit. And what I've done is I've turned this up to about 30 different workloads running at the same time. And what we're going to do is we can see already that we've got these purple lines being drawn, these vertical lines. These are called annotations in PMM. And the usefulness of these, there's a multitude of different places you can use it. We've decided to show it as the workload modifies, that it will reflect the line, and then you'll be able to see the deflection point in your graphs and be able to attribute those deflection points to something significant that occurred. Working with some customers at Percona, oftentimes they'll want to use it for when they have a code release. That's a popular time to do an annotation. Or perhaps if your cloud provider has any type of an event, you might want to annotate that on your graphs. The point being is a nice line can describe to you some external activity that occurred and how did that impact your database performance. And so I'll talk really quickly over some of the different things you see on the screen. Some of these graphs take about a minute or two to update, and that's because of the different data sources that are being used within PMM. So at the top, I showed the 3 most important graphs. Down below, you can see that we're providing a view of query analytics, a little bit different than the other section of PMM. This one here is one that Matt pulled together and is able to show not only just the queries that are running or that have executed, but some other characteristics about them, such as their count, their average runtime, their max runtime. This is really helpful stuff if you can plot that at the same time over the database characteristics. What is the response time changing? And now we have a long list of the different queries that are running. One of the neat features, though, of this actual dashboard here is we can pop into another window. Oh, let me see. I think I need to switch over to that window as well.
Yeah, because you're not sharing your.
That's right. That's right.
So they have stopped sharing. If you want to stop sharing and reshare. So Michael's going to quickly stop sharing for a second and flip over to the one. So just share Chrome, I guess.
Okay, that's a
or
good idea.
Full screen. Either way.
Okay. Share.
And now you might see us multiple times. Oh, I got to let Michael in. Go ahead. And there you go.
Sorry about that technical glitch. So we're back. So we've got we've got a secondary dashboard here that lets us drill into each of the individual queries. And what's really cool about this is it'll give you per query statistics over the performance of this one query. So we can look at the response time here on the right-hand side. How has this query been modified over time? And then the number of times that the query has been running is described by the database queries per second. The graphic that I like the most, and I think we might be able to come back to this later as the workload is changing, this view shows us every minute what has been the performance of this query. And what's cool about this is in a standardized environment where not too much is changing, you would expect that your query response time would remain fairly standardized. But we can see in some instances that there are increases, considerably larger, in some cases, 2 or 3x. And what we can describe here is that we've made other changes within the environment. We've added and removed indexes. In the case of PostgreSQL, we've done some vacuum operations, etc. So all of these external factors will impact individual query response time, even if you haven't changed that query in and of itself. And so this is a great tool for people to be using to visualize the performance of their database environment.
And so now you see the workload that you changed a few minutes ago is starting to pick up.
That's right. That's right. We can see as I modify the number of workers, obviously that increased the number of connections to the database. Right now, we're still able to increase the volume of queries, and we actually are able to see that the average response time is coming down. So generally, that's a good thing. You've increased users on your website. Thing to pay attention to, though, is that most resources in the world are finite. And what we're also doing on this dashboard is plotting the CPU utilization. And we realize that we don't have very much more headroom here. We're floating around 90%. So there is going to be a limited amount that we can go any higher here.
So I wonder if we have cleaned up yesterday's, because we were able to get 15, 16,000 queries a second with this workload. So I'm wondering if maybe we, let's see if we,
Are you putting a challenge to me?
We're gonna put a challenge to me. Michael's gonna try and tune this, Postgres instance, which Michael likes his MySQL better. He's not the Postgres guy that he used to be. So we're going to see what he can do to maybe get a little bit more performance out of this.
Okay, let's see what we can do. First, we're going to increase the number of workers on the application. So I'm going to be a little bit crazy here. We're going to go from 30, and maybe we'll take it up to 50.
Now, wait a minute. You were already 100% CPU bound.
That's a good point.
So you're going to add more workers to 100% CPU bound workload. That seems weird.
That's right. That's right. And I don't know where this is going to go. This may or may not work.
Wow. He's brave. He's brave.
One of the cool things that we can do with this deck here in front of us is actually got 4 different types of workloads on it. The first knob that I keep touching involves primary key and secondary key lookups and a minimal amount of writes. So if I really want to just tune for making things as fast as possible, get the number of queries up, it's going to behoove us to be using primary key as much as possible for any types of queries. I'm going to try to turn off some of these excessively long queries and probably turn down the number of writes. That's the first place I want to go. Generally, databases will perform more quickly on read-only workloads than they will for writes. Reads mean first maybe fetch it from disk the first time, but otherwise you're often working on a memory-bound workload. And reading from memory is obviously faster than reading from disk. If you turn that around and you talk about writes, it'll be very difficult for us to really scale writes any faster than reads because there are additional operations involved in order to persist the change that you wanted to make in the database.
But a lot of those are going to be offset, right? So you're only bound in a lot of cases not by the actual insert updates. A lot of it's the checkpointing, which if you've set your settings properly, it could take a really long time.
That's right.
Checkpoint. So you might actually get good insert throughput, right?
Well, each database technology is different. Postgres and MySQL have different types of checkpointing, right?
Yes.
One that comes to mind with regards to Postgres is involved to the vacuuming process.
Yes.
And that one can sometimes be challenging in terms of what behavior or what impact that's going to have on your environment.
Yeah.
So in our case, sometimes you want to be able to schedule that. Sometimes you might want to be able to demonstrate in terms of a live demo what the impact of running a vacuum during a business period of your time would be.
Are you gonna do that?
I'm a little bit interested in seeing what would happen here.
So
Will you let me hit it?
Yeah, hold on. So we'll have to go up to the top.
Okay.
So let's see what your changes did thus far. So what do we got here? So you're still.
Well, I'm ready to flex a little bit. I got to about almost 14,000.
So yeah, so 14,000. So he turned off some of the workload because there's some long running transactions. If you didn't see on this guy, here we'll just go ahead and flip this over so you can take a look at what he's doing. We've got these different knobs here, and each of the knobs, when you turn it, will increase one sort of workload. So there's reporting workload, there's this heavy insert workload, and then there's long transactions. So originally he had all of these turned up because he just likes to touch buttons. That's just how he rolls. But before, to get more throughput, he turned off some of the workload. So he cheated a little bit, basically, is what I'm saying. Is he wanted to crank buttons, and then he didn't want to fix the buttons that he cranked. So never, great there. But hey, whatever. All right, so let's go ahead and look at what happens when you run a vacuum. And right now, obviously, Postgres has auto vacuum, so and there are thresholds you can set, but you can run vacuum on its own as well. So go ahead and hit the vacuum button. There's a vacuum button on this thing.
Finger coming in.
You can see it on the side.
Clicked away.
There you go.
Yeah, it's been started.
All right, so now he's going to run a vacuum. We're at 14,000. So part of this, and part of the cool thing, how you can deploy and use PMM in a production system. Hold on, I'm going to flip us over so we can talk while that's running, and we'll come back to the screen. One of the cool things about using PMM in a production level system is you can use it to do benchmarks and test different code releases, right? So you can see what the impact of certain activities are. If you added an index, removed an index in test, you can then run your workload and see what those differences are. You can check different code revisions, right? And so one of the powerful things about Grafana that we include in PMM is the ability to do annotations. And so every time we click a button, every time you deploy code, you could write an annotation that says this code was released, and that provides you with a really powerful way to see what happens over time, right? So you go to bed, you don't know what happened overnight, but if your code is instrumented and it's calling the annotations you need, you're going to then potentially be able to find that needle in the haystack a little bit easier. Mm-hmm. Now, let's flip back to your screen because I see that some things have changed, right? Look at that.
What happened to our database queries per second is what I want to know.
Yeah, so scroll down a little bit because I think that's the interesting thing. We went from 14,000 to 3,000, and it's going to bottom out actually. So you can see that the queries per second, on there has just like plummeted. I mean, it's gone off the charts low because we're actually vacuuming and cleaning up the table that is mostly being hit by the workload we're generating. So, I mean, it's definitely something that you see that impact. And that's, it's something that people intuitively know. Everyone says, don't talk to me about vacuum settings again. But from a vacuum perspective, it definitely can impact performance. And that's why making sure that those auto vacuum settings are set. And there are some companies who actually try to delay a vacuum forever. We just can't afford to do it. And it just gets longer and longer and longer. And there are all kinds of other consequences that you can have because of it. Mm-hmm. Mm-hmm. Okay. All right. So why don't we flip over to some MySQL workload because you're more comfortable with that. The vacuum should finish in a second. Why don't we give that a second to wait? Michael, you used to be the product manager for PMM. You've been around PMM forever and ever. And we've seen this deployed all over the place. What are a couple of interesting things that people might not know about PMM or the capabilities of PMM?
That's a fair question. Again, this is unscripted.
That's how we go.
That's
right?
how we roll.
It's unscripted.
One of the great things I think I like about PMM is that once you get it deployed, you can instantly be useful with it. That means you could be making observations yourself as a database administrator or as an application developer. And what I love about that is it enables a conversation between those two teams, which are often very close together, but are looking at different types of tools to measure database performance. A common refrain that I hear from a database side is that queries might get thrown over the wall, and they're just left with a little bit of extra work on the database administrator side. And what PMM allows you to do is to highlight the differences and maybe offer some recommendations towards indexes or some other query tuning opportunity and share that back with the development team. And what that enables you to do is to make modifications in production. And if you're deploying this through multiple different environments, you can also use them in a pre-production environment. You could be having these conversations while it's still in dev or in staging.
And a lot of this is extensible, right? So I've been digging more and more into PMM. And so the dashboards you see are the custom dashboards that I built myself. This is all, you are capable of building dashboards how you want to present the data. And so that's an important thing for you to, understand is just because out of the box, it might not have the graphs in the right way that you want, the right colors. It might not have the right data even. Maybe you find some things more valuable than others. It's really extensible. You can write your own exporters because, if you've written things for Grafana or Prometheus, it's fairly straightforward. You're going to be able to do things fairly quickly.
And staying on that theme, I like that with the extensibility. There's two main ways you can take an existing PMM deployment and make yourself even more productive. For example, if you already have MySQL or Postgres deployed, you can use what we call custom queries. And what that lets you do, if you can write a select statement to fetch a metric out of your database, you can turn that into a series that you can then plot on a graph.
So is that going to just plot every row that's returned?
Well, it depends on how you write it.
Okay.
So you could be writing something that's unique about your data set that Percona is never going to know. For example, you could be counting different types of users that might be logged in. So the answer to a select query against the user table saying, or how many admins are online right now, or how many.
So I'm going to put him on the spot. Can you do that with the database we've got running right now? Now, I'll even let you switch to MySQL because I know you're more comfortable with MySQL. Do you think that you could do something like, I don't know, let's count the number of comments that have been entered into our chat system in this workload?
I think we could do that.
Oh,
I think we could do
we're
that.
going to do some live, like extensibility stuff here with PMM, which is great. So let's go ahead and let's just jump back over to the screen showing the this, and just to show you, vacuum finished. So obviously all the, traffic went back to where you would expect it. We also have the capability, like I mentioned, to drop indexes, rebuild materialized views that are running. We also can deploy schema changes. So we play with that one with MySQL in a second, but we wanted to test the difference between different data types. And so we can test and see visually what happens when you use a varchar versus an int as a primary key, which we all know there's a lot of performance impact there. So we'll show you how much after Michael shows us how to make some extensibility changes. Now he's going to start to click the button, so I'm going to flip over to the machine, and so you can watch watch him flip. Right, this is where he's going to go. He's going to go switch to MySQL now. Well, let's reset the Postgres first. So the red button, which you tell everyone not to hit, I just hit the red button.
And you know what's amazing is how many times I've told people not to touch it, and what did they do?
They touch it.
They touch it.
Yeah, Peter's like, ooh, what does this do? What does this do right here? And so, what that does is that full stops all of the workload, just so everybody's aware. It totally stops everything and resets it all. So right now, you can't see on the screen behind us, but, we have the log for the controller out. and it has set everything to MySQL, and we're inside the load functions. We've loaded actors and all the titles, so that way when we generate workload, we're not searching for a title or something. We have a list, and then we randomly select actors or directors or other things. So all of this is based on the Internet Movie Database, all open data that you can go get and play with yourself. This is also all on GitHub, so if you wanted to replicate what we're doing, you can do it as well. It's on my GitHub, and I'll leave a comment with that in the comments. So I'll just put the link. So, Michael, we are now on MySQL, and look at this. I'm going to spin this. I'm going to spin some dials here. I'm going to give us some workload because I like to do the spinny things. It's like a mixed master. We're going to also add some of this. The insert, update, delete workload here is also where most of the comments and chat occur. So, so there is that. So we can't see your shell. So I don't know if you wanted to share that.
Me.
Because you're just sharing your PMM now. So why don't you share your whole?
That's probably safer.
Just share it all. He's going to share it all, everybody.
Here we go. Entire screen.
Okay. Now you've got to.
Okay, take it back to.
Go to where you want to go, and all right. So here he is. Here's his shell. Hopefully he doesn't, type in his password or anything that he doesn't want you to see here. But let's go ahead and let's take a look at that, shall we?
Okay. All right. So we're talking about custom queries, and what that really means is if you can write a select statement, you can start to visualize some data. Where are these files located? They're under quite a lengthy path under user, local, Percona. And then under here, we've got other products often that are installed. You'll be looking for the PMM2 directory. And then I believe it's under collectors.
That's a little better. Easier to see.
And we want to do custom queries. I'll talk about text file collector in just a moment, but custom queries is where we want to start. In our case, just checking, we've switched over to MySQL. So let's go there. Okay, we're almost done. Look, we're already quite deep, about 6 levels in. I'll speak quickly about this. We've got 3 different resolution levels. It really means how often do you want to collect the kind of data that you're interested in. So high resolution will generally get it for you every second. Low resolution will get it every 60 seconds. And you might want to do that because the data is changing frequently, so collect it more. But there's a cost usually associated with queries, so maybe you don't want to overload your system. So let's go into the high one because we just want to have fun here. In here, you'll notice we've already got a couple different examples. We're going to modify an existing example in the queries MySQL D.
Oh, okay.
And I'm a Vim guy. I don't know about you, Matt. Are you?
Yeah. I'm not an Emacs guy.
Okay.
Oh. I'm sure that kills some people. Oh, yes. So you didn't have permission.
I did not. All right. I got the password right the first time. Good. I mean, it's a big day for me, right?
The good news is this box gets wiped after this conference and it gets reset. So if you accidentally do fat finger that ultra secret password we used here.
So what I'm going to show here, we're going to keep this simple, and I'm just cleaning up an existing example. What I want to be able to demonstrate is we're going to take a select statement and we're going to run it, and it's going to return a metric series and a label. Anytime you want to have a query run, you probably want at least 2 of those fields. One, the metric series is the actual number that you want to be able to plot. So I've shown where we'll be editing. I'm going to jump out of here, and I'm going to get into the MySQL instance. Unless you know off the top of your head what the schema is. Could we write it without even looking in the database? How brave is that? Maybe that's too brave. Maybe that's too
Show
brave.
people what you're going to do. It just makes it easier for posterity's sake because this will live on the internet. As you all know, things on YouTube live on YouTube forever because they never get deleted. And so in 1,000 years, when aliens discover the remnants of human civilization, they'll find your video and know how to do this.
My life will be complete at that point.
I know, right? You will live in infamy forever.
So let's take a look at what tables we have in here. And
so you're going to want to use the user comments table.
User comments are the...
Yeah, so you movie normalized user comments.
Okay. So here we go. So we've got the option of using a few different types of labels out of here, and I think we're going to want to look at what was the challenge? It was to
count. Let's count the current active comments that are out there. So, you know, we're going to just say like, hey, at this data point, this point in time, how many comments do we have?
All right. Well, we're just going to count the table then, if I'm not mistaken. I don't see.
Yes. So you're going to count the table and give it a time. So we're going to make it super easy. I'm not really challenging you. Wait until the next challenge, which will super challenge him, I'm sure.
Well, already you can see I'm challenged on getting not making any typos here. All right, we'll put the table name back in. And we'll just get a real quick count of how many rows are in this table. Well, that's quite big. So we've got about 4 million rows in this table. And if I'm not mistaken, our workload will be modifying this up and down.
It ups, deletes, right? So it's probably overall, as this runs, it's going to get bigger and bigger. Just like your data probably never gets smaller.
And look at that. So I just ran the select a couple times, and I already have some different values in there. So this is going to be a really good place for us to start to be able to demonstrate this.
Right. You should see it go up and to the right, you know, because even though it's deleting, it's only deleting comments that were in the last 5 minutes because somebody posted something. They go, ooh, I really shouldn't post that, right? So I'm going to go ahead and delete it.
Exactly.
Right.
Exactly.
So the 5-minute regret rule, if you will.
So with that information, what we've done is we've quickly composed a select statement. We'd encourage you obviously to make it more complex depending on your needs, but we'll start with a count of the number of rows in a table. I'm already in the directory where the high resolution is, but now that I notice it takes around anywhere from 2 to 5 seconds, running it every second may not be a great idea. I'm going to back out of here.
Yeah.
Because I don't want to swamp the server, right?
Yeah.
I want to be sure that I don't cause an outage maybe. Or
That's true. That's true. Is there anything we could do to speed that up?
well, I guess we could have maybe an index.
Could. What are we missing?
Well, in this case, the primary key is already defined on comment ID, and it is an integer value. I'm not sure what else we could do here really to make this one much quicker. Would you have any ideas?
I'm asking you as the expert. See, he's trying to throw it back on me, but I invited him. I'm the facilitator. I'm the host, so I'm supposed to make him look good or bad. You know, depending on, you know, the mood.
Well, I'll leave that for something we can debate a little bit later.
Okay.
What I'm going to do is I'm going to move it into a lower resolution environment because I probably exaggerated with causing an outage. What would end up happening is you'd have one query maybe stepping on the next. The first one wouldn't finish, and you'd be running additional.
Well, and it would basically cause a pileup, right? Because you would always have it, and I think your queue list of those would just get longer and longer and longer.
That's correct.
And so you would see the rest of your performance go. So okay, There you go.
So we'll come back into the low resolution.
Low resolutions every minute.
Yeah, we'll play it a little bit, a little more aggressive here on the medium side.
Ooh, crank that one up.
Let's get this out of the way. I can't see. There we go. So okay, so we're looking at the queries. Oh, I'm sorry. I need to be doing this as root. And did I get it right? Oh, I love that. Okay, so how does this work? There's a special format. It's a YAML file. And easiest if you just use the existing example to get you started. So what I've done is I've just removed the leading comment markers, the hash symbols. The very first component is what the start of your metric series is going to be named. So in this case, I'm not going to use Mysql performance schema. I'm going to remove the performance schema component. And I'm going to put it in, I don't know, OSS Demo. It can be any text string. What this is going to be, I'll illustrate this in just a moment. You'll be able to go into PMM and discover this metric series, and it's going to start, in our case, Mysql OSS Demo. All right?
Makes sense.
Okay, so I've started that. And then in the query block, you could imagine I'm going to remove the existing one, and I'll paste in quickly the select that I had written already from the given table. Okay? And then I'm actually going to fix this just real quick. I want to give it an alias, so it's a little more complete. I'll call it count, CNT. And then down here, you want to give it what is the matching column that's coming out of it. It will be called CNT.
So would it be beneficial in this case to use a more descriptive thing, or does it matter at all? Like comment count, or, you know, because if you have a lot of CNTs, you know, you might be counting 3-4 different things. You know, might be better to differentiate that way.
That's a really good point. That's a really good point, because what's going to happen here, it's a series of appending names together.
Right.
So in this case, if I just left it CNT, the full metric series would be called MySQL OSS Demo CNT. You raise a good point. That maybe it's not very self-descriptive.
So I wouldn't know what I'm counting.
That's right. That's right. So let's call that comment CNT, and we'll fix it up down here. Oops, I went down one too far. Comment CNT. Okay.
Great.
You've got one last decision point to make. You can choose to use either a gauge or you can use a counter. And this is an important determination because it impacts how Prometheus, how the database system is going to be able to plot your number. In our case, this count we know can go up or come down. So that's a gauge. Gauges are things like temperature. Temperatures go up and come down. Trade that off with a counter. A counter is a number that's always incrementing. So if you look in MySQL, for example, how many users have connected over time, that will be a number that just keeps growing over and over. So it leads to different formulas that you can use on your dashboards.
So this could go down in theory. So it could go up and down. Most likely it will always go up, but it could go down.
Yeah, so we'll provide for that just by giving it a gauge. And then the last part is this description. I'm just going to leave it alone for now. Really all that it does is it provides a helper for when you want to look directly at the output of this exporter. It's kind of a low-level thing that you don't need. It doesn't impact the performance of it.
Fair enough.
Okay. So that's it. So you've made your modification to this file.
So how do I get it to work now? Like how does it start collecting? Does it just pick it up?
You simply just save your file and exit, and automatically the PMM client is going to start using this file that has new entries in it and start fetching this metric series for us.
So it should be fetching it. You did mediums. How often?
I believe it's going to be every 5 seconds.
Every 5 seconds, this is going to be collected. So how do I get that now?
Okay. Well, let's validate if we've done everything correctly.
Because, sometimes we need validation.
And it's a live stream, so let's just make sure that we did everything correctly. We have this kind of hidden, and there it is, a dashboard called Advanced Data Exploration. And what I'm going to do is I'm just going to pop this in another tab. And what it allows you to do is to explore your different metric series that are in your database system. So you'll find many of the common MySQL ones that we use on different dashboards. In our case, I'm going to start searching for MySQL OSS Demo. I'm crossing my fingers that it's going to be there. Let's see if we can find it here.
I don't know, Michael. The crossing your fingers part? Whew.
Oh, it's not there yet. It's not there yet. Well, all is not lost. What do? You go to the logs. That's the first place I want to go to.
Fair enough. Show us the logs.
Okay.
Take us to the log files.
Now, the beautiful thing about the PMM client, it's available as a Debian package or as an RPM, or you can download and use the tar files. And of course, like all of Percona software, it's open source, free to use, so you have access to the source code. Happily take your PRs if you want to go deep and send us some fixes. The point I'm trying to make is that it's also integrated with systemd. So in our case here, I'll be able to look using journal control to see what's going on with this client. Journal CTL. I want to describe it as the unit called PMM agent. And we're going to hit enter here. Oops. Not if I spell journal control incorrectly, though.
Oh, my gosh.
Okay. Journal CTL. There's an L.
That would make a big difference.
It certainly wouldn't work. Did I get the password right? Okay, there we go. Oh,
there we go. So what do we got?
Let's make this a bit smaller here.
Oh my gosh, it's so tiny. It's so tiny.
Is it too tiny?
No, well, I think it's fine for those watching at home, but it is kind of tiny. So what are you looking for?
So what I'm looking for are really any errors here. I'll describe quickly what I'm seeing, and then we'll see if we can decipher if there's any problems coming back. You're going to get two kinds of errors logged in here. Or sorry, not even necessarily errors. We've got the two different kinds of exporters running generally. You've got an exporter that's connecting to the database service, and that's called Mysql D Exporter.
Okay.
That gets you anything MySQL related.
Okay.
It sounds like. The other one, depending on how you've orchestrated it, you'll either be fetching your query logs from the slow query log, or you'll be getting them from performance schema.
Okay.
And what that enables is it'll provide a view of which are the slowest queries running in your environment, and that's what you see on the query analytics dashboard.
And when we talk about Postgres, that's going to come out of either PG statement or the new PG monitor.
PG stat monitor.
PG stat monitor. So
Mhm.
either one of those.
Mhm.
So similar locations, just different sides for each of the databases.
Okay, so they come with two different kinds of logging formats. These earlier ones up here where they're showing a level info database version, that's coming from the Mysql D Exporter. Generally, the Mysql D Exporter works quite well. It's not very chatty unless there's any errors. There's only ever this repeating what version are you running.
Okay.
Okay. The slow query or the performance schema source also is relatively low volume, but what I like about it is it'll show me status. So in this case, it's showing me how many buckets of data had to be sent up, back up to the PMM server.
Okay.
So you're generally looking for numbers that aren't 0. We want to make sure in our case we've got 50 or 17 buckets. Okay.
Makes sense.
So this is a healthy looking system. What I'm looking for is actually something that isn't, sticking to this 50 or 17 buckets or the same database version in here. I'm going back quickly here in the logs. And I'm looking for anything that says, I'm unable to connect to the database and run a select statement that is account. Let's try one more time. I'll do it with the dash XE, so I'm at the bottom.
Wayne, we'll get to your question in a second.
Oh, Matt, you're not going to believe this. I don't see what the error log is for this.
What?
For this failure here.
How do you know it failed then?
Well, how do I know it failed? Let's try searching one more time and crossing our fingers. Maybe everybody at home can cross your fingers for me as well.
Michael. Oh, man. Okay.
Yeah, so MySQL.
It's okay. It's okay. I can be within 6 feet of him. He has the green bracelet on. So
2 green bracelets on.
So he wants hugs.
Oh, Matt, I've got some sad news. I don't immediately see why we're not fetching back this data set.
Oh. Did it save it properly? You check maybe the permissions on it. I mean, maybe you exited without saving it, so it didn't get the medium.
You're
or
right.
Is there something that could be running, or that it's not running those things? Do we need to restart? You need to refresh the browser.
When in doubt, restart. I'll just check the logs one more time here and see if we see anything. Okay, we can see that things did get restarted. Now we can show that it's running on the new port. We've got a whole bunch of other Victoria metrics data coming back. And we'll just check one last time. And maybe if we don't have it working here, we'll move on to another example. Okay, I'll refresh the dashboard.
But this just means that you have to come back and do a video where it actually works.
That's right. That's right.
Because I can't have like a video that goes halfway through and like here, everybody, do this, and then it doesn't work.
I mean, what if the aliens are looking at it like you were speaking?
I know. It needs to be here for posterity's sake.
So here we go. All right. So MySQL OSS. Oh, breaking my heart. It's just not there. I owe it to you, Matt.
Where is the data stored?
In this case, it's stored in a system called Victoria Metrics, which is a fork of Prometheus.
Okay. And can you go to Victoria Metrics and search for it there?
We used to be able to do that. The paths changed when we did a migration from Prometheus to Victoria Metrics. But let's give that a try. Let's see what we can do off of that. We'll take the URL, put it in a new tab here, and we'll call it Prometheus. Oops, spell that correctly.
Because, I mean, one of the other things that I know you can do within the dashboards, right, is you can do a query inspector. So could we look through that?
Oh, you're right. You're right. We do have the explore function within. If you use this button up here, I think it is. Is that explore?
Yeah.
Right
Yeah.
there.
So you can do it on
I'll
your
do it
screen.
on my screen.
And Michael has 17 minutes of battery life left before his battery dies.
Here we go. So we'll explore. This is a great little way that you can just jump right into looking at not only your metric data, but it also lets you explore the ClickHouse data.
Yes, yeah, it provides a nice interface for that. So are you going to look under the metrics then, or are you going to look under one of the other ones?
Yeah, I'm just going to show the different options here. The default is going to be metrics. That means Victoria Metrics.
Okay.
Okay, so that means anything you start putting in is going to be reflected from your metric series, your time series. So if I start putting in MySQL, it's already going to do a look ahead and find any matching metric series names. Many of these we're using on different dashboards to highlight and draw different graphs.
Yes.
But as soon as I get a little more specific and I put in OSS, yeah, it's showing me that it's not in the Victoria Metrics database. So there's a disconnect between the client and this.
So what's going to happen is Michael's going to go off and, when he gets it right before the end of the day, he's going to come back and he'll record a video and we'll post the supplemental here because that's what we do here.
That's what we do.
We close the loop. So he got me interested in a feature that I hadn't done because I hadn't done the custom MySQL queries yet. So I wanted to see how to do them. And so, he showed me a little bit there. So we have been running MySQL workload now for a while. So Mr. Michael, you want to go ahead and show us one more thing before we go and answer some questions. So we mentioned a little bit earlier that we are doing some schema changes and looking at potential code deployments and things. So if you recall, I mentioned here, these buttons are actually some fun buttons. Well, fun in the sense that we've written a lot about this over the years, about the differences between an integer and varchar performance. So you can see that what do we got? What's our current queries per second count?
Oops.
So we're at about 4,400. We can make that go higher if we wanted, but we'll just use the 4,400 for the time's sake. What we're going to do is we're going to flip on and we're going to change everything over to use a varchar primary key just on one of the tables, and as opposed to an integer. So that's what that's going to do. So this click right here, you can't see it on the screen behind us, but it actually wrote to the logs that, hey, I'm making this change to change this particular table to be forced to use a UUID or something similar. And so what we're going to see in Michael's computer that hopefully won't die is we're going to see the drop in performance.
And that's a really good point you raised about the varchar change here. We're not changing the data itself. It's still going to be a number, but it's going to be evaluated as a string. And why this is it's quite significant is that many database clients or frameworks, really, as they work with a database, they like to choose clever primary keys. A common one is a 36-byte UUID value.
Right.
Guaranteed uniqueness. From a perspective of usefulness, it's very, very helpful. But there's two main problems with that. One, it's a string, and we're going to show you the impact of it. And two, it's quite large.
Right.
Right. So 36 bytes. One of the unique characteristics of MySQL and InnoDB is that every single primary key is part of all secondary keys. So that means the wider your primary key, every additional secondary is going to be that much wider, and that leads to increased memory and more disk activity. So you generally want to keep your primary keys as small as possible.
Yeah, we've seen a big drop in the queries per second and the response time, but that was specifically because of
I just lost it.
Oh my gosh, he lost it.
Oh dear.
Oh, well, so we're gonna he didn't charge his battery. Oh,
and yes,
so
yeah,
bad.
I left my charger I left my charger upstairs.
So we can look at the graphs behind us a little bit. It's a little bit harder to see, but we should be able to zoom in once we get these things going. So the time here is not in the right time. Okay, so you can see here, I'm going to zoom this in so we can see. So this is our queries per second. So obviously, what we did here, this annotation that you see here, if you hovered over it, it would actually show you that the primary key changed, or the start happened. So we have, it's actually done. So the log does show that it's done. So we're going to see what that queries per second ends up with. Now, again, this is the exact same workload. This is the exact same everything, except for just the varchar primary key versus the integer, right? So a very small change. So imagine if you're going to go deploy new code and you want to test version A versus version B, because let's be honest, a lot of the problems we see from in our support or managed service are because people didn't design the database right. They didn't think about it. They just chose whatever was default, and that leads to a lot of those UUID type situations. But if you have something that you're going to deploy new code, you can run a test. before and after, and you can compare those, and that's what we want to see. And so in this case, you see a little bit of rebound here, right? So these are in 1 minute buckets, but you see this went up a little bit. So let's give it like 1 more minute here and let's see, because it should stabilize. But remember, this particular workload was about 4,500 queries a second. And so we can come back, and now we got another data point here as well. So let's go ahead and let's go back to the general. So these graphs right here, which you can read the numbers, there should be big enough. You can see that this is the peak. Over the last 15 minutes, we peaked at 4,512 queries a second. Here we have, the average, which is 3,091. And you can see right now we're running 421. So this particular thing was over a 5x decrease in performance just by making that small change. Now, if we alter the query workload a bit, add in a little bit more aggregates, add in some inserts, updates, deletes, and we throw more threads, what we'll see is we were getting yesterday when we were doing this a 30x difference in performance. Mm-hmm. Right? So it was massive. We were hitting 17,000 queries per second. You make that one small change, and all of a sudden we're down to 500 queries a second. So anyway, so that's what we have for you today. Wayne wanted to know if we're going to be working on a client for the ARM architecture, and that's something that we have talked about. I don't know the current status of it. I don't know if anyone is online on the live stream here from the PMM team. Be happy to get back to you on that, Wayne, on Discord, if that's helpful. I don't see any other questions, but if you do have other questions, we're here at the floor show. It is still pretty early, so not many people have showed up. The show floor doesn't open for another hour or so. Mm-hmm. So we're still a little alone. There's been moving some things around, adjusting some things here, but it's just been us for most of the morning. So, what do we got? Do we get another one here? Let's see. Oh, Wayne says, cool, thanks. So he'll check on Discord. We'll get back to him offline. And Michael promises you that he will get this fixed today as soon as he gets a plug for his laptop.
Exactly that.
You should have waited until your laptop died to say, like, oh, I can't do anything else. It would have looked way better. I'm just saying, next time, try that. But everyone, thank you for joining. If you've watched this live, wonderful. If you're going to watch this later, also wonderful. If you have suggestions on what you'd like to see us show you in PMM, if you'd like to come on and show us some cool things you've done in PMM, come next time, and we'll dig into it. And for all of us, thank you for coming. And we're Matt and Michael, and we're live from OSS, and we'll see you next time.
Thanks, everyone.